Okay guys, today we're going to talk about fundamental identity and where they come from. So if we remember our graph here, x and y axis are old friend, and you might know that sine equals y over r, cosine equals x over r, and tangent equals y over x. And if you don't know that, then you can recall something called SOHCAHTOA to get the same thing. And because we know here is our x, here is our y, and here is our r, if we assume this is on a unit circle and this is r here. So SOHCAHTOA, you can actually confirm it by, see, SOHCAHTOA is opposite over hypotenuse. So opposite over hypotenuse, that is sine value, which is y over r, which is what we got here. And cosine is adjacent over hypotenuse, which is x over r, which is what we got here. And tangent is y over x, which is opposite over adjacent, and also what we got here. And so we got that part covered. And here, the reciprocal of sine theta is called cosecant theta, and it is a reciprocal of sine theta, so it equals r over y, or sometimes 1 over y when r equals 1. And the next one is, the reciprocal is secant theta. It equals r over x, or 1 over x if r equals 1. And the reciprocal of tangent theta, it is cotangent theta. It equals x over y. Okay, so the next part is our fundamental identity. Okay, fundamental identity tells us that sine squared theta plus, let me change the color, cosine plus cosine squared theta equals 1. And this is true. And if you don't believe this, we can prove it here by saying that y squared plus x squared equal to r squared. And this is the same if you just divide everything by r squared. Then you can see this is exactly the same thing as here, since our sine value equals y over r, so y over r here squared equals sine squared, and same thing for this too. For this one, it goes to here. They are the same thing, if you can see it from here. Okay, and of course this part equals 1. Okay, so we got that part covered. And now the next two fundamental identity is just another, this one in another form. And by that we mean we can prove it by dividing 3 of them, all of them by, let's see, by sine squared theta, sine squared theta, and sine squared theta. and that is just equals this here. This become 1 and a cotangent square and cosecant square. That is the same thing. And this is a another one. They have 3 of the fundamental identity, and this is the second one. Okay, so we got another one. Another one is the same idea, which is this one divided by cosine squared theta. I'll write here, so make it more clear. Now this is, I'm just gonna copy this here, top part. And this time we will divide it by cosine. Cosine square of theta. And this is just the same as tangent square plus 1 equals secant square theta. So there you have it. The 3 fundamental identity proved. Okay, thanks for watching. I hope you find this video helpful.